Hello, this is solution to homework 4B, and this is problem 1. It talks about a boat that is going downstream with the river and then coming back upstream, that will be against the flow of the river, and it asks you to calculate the total amount of time it will take in the round trip. So let's illustrate the idea using, so this could be the river, two banks of the river, and let's say, oops, the velocity of the river with respect to ground. So we have B for boat, R for river, and G for ground. And quantities in the subscript means this is the velocity of the river with respect to the ground. That's given to be 5 meters per second. And the boat itself can go at so velocity of the boat with respect to the river is 20 meters per second. So let's say that this is a initial point, that's the final point, and the distance d here is given to be 3 kilometers, which is 3 into 10 raised to 3 meters. The total time that the trip will take would be the time taken for the downstream journey plus the time taken for the upstream journey. The time taken for the downstream journey will be the distance d divided by the velocity during the downstream journey plus this. The time taken for the upstream would be the same distance d, but this time the velocity for the upstream motion. Notice that velocity in the downstream motion will be velocity of the boat with respect to the river plus the velocity of the river with respect to the ground. Since the river is going to be flowing in the direction of the boat, the total velocity will add up. And in the upstream motion, we have velocity of the boat with respect to river, and the velocity of the river itself is in the opposite direction. So this will be subtracted out. So overall, we have d the distance over velocity of the boat with respect to the river plus velocity of the river with respect to ground. So this takes a smaller amount of time because the denominator is larger, which is what intuitively we expect. And if we put this all in numbers now, this will be 3000 meters, to two significant digits if you want, divided by 20 plus 5, and while coming back is 3000 divided by 20 minus 5. So that's 3000 divided by 25 plus 3000 divided by 15, and that's 12 plus 120 plus 200. It's 320 seconds which is about 5 minutes 20 seconds. So there's two sig digits, so we should say it's 5.05 minutes. So that's this is it. Since both the velocities were in the same direction, it was either addition or subtraction. It was really uh, reasonably intuitively clear. We'll come back to other examples where the velocities are in different direction in the next problems. Let me pause here for a moment. Problem 2 in homework 4B discusses raindrops falling and how it is perceived as if it is coming towards you when you're driving through the rain. So let's have the following vector represent. So, so this vector represents, maybe let me undo this and show this as, so that's the velocity of the rain with respect to ground, and we are told that it is falling vertically down. So R is rain in this case, G is ground, and we have C for car. So that's velocity of the rain with respect to ground, that's vertically down, and the velocity of the car with respect to the ground is towards the east, and that's given to be as a magnitude. Velocity of the car with respect to the ground as a magnitude is still in the direction of east. That's 40 kilometers per hour. That's 40 into 1000 meters divided by 60 minutes times 60 seconds, which is 40,000 divided by 3600, and that's 11.1 to 3 digits in meters per second. The traces of the rain on the side of the windows makes an angle of 76 degrees with the vertical. For that purpose, let's see what is the velocity of the rain as seen from inside the car. So that's the velocity of the raindrops with respect to the car. That will be equal to velocity of the rain with respect to the ground plus the velocity of the ground with respect to the car. But velocity of the ground with respect to car is minus velocity of car with respect to the ground, and that explains that we should be looking at the sum of these two vectors. So that's velocity of the ground with respect to car. So this will be, this line here will represent velocity of the rain with respect to car. Oops. We are given that this is 76 degrees and this is 11.1 meters per second. So this is a right triangle. Once we have this vector equation clear, we don't have to really split this into vectors because right triangle formula is significantly easier. So we learn from this right triangle that magnitude of the velocity of the rain with respect to ground satisfies the following equation. This is magnitude, and that's tangent of 76. That's coming from this right triangle here, and that immediately implies that the velocity of the rain with respect to ground would be 11.1 divided by tangent 76, and that's 2.77 meters per second. So it's a significantly smaller droplets. Heavier droplets or typical raindrops are about 6 meters, 6 to 8 meters per second. So once we have the velocity of the rain with respect to the ground, that gives us two sides of this right triangle. So we can calculate velocity of the rain, magnitude of the velocity of the rain with respect to the passenger in the car to be equal to velocity of the ground with respect to car square plus velocity of the rain with respect to ground square. That's equal to 11.1 square plus 2.77 square. And take the square root. So that's square plus 2.77 squared. That's 11.4 meters per second. So the rain seems to be coming at a faster speed because it's adding on to the speed of the car itself, and it falls, of course, at an angle of 76 degrees with respect to the vertical. That's part A and part B, actually. So this is part B, and that's part A. Let me pause here, and in problem 3 of homework 4, uh, uh, the discussion is about an aeroplane that is trying to go north, but it has to head in a certain direction so that it can compensate for the wind that is flowing north of west with a speed of 20 meters per second. So let's have a diagram. So that's east, that's west, and we have north. We are told that's the velocity of the wind with respect to the ground. It is 30 degrees north of west, and we're given that this is 20 meters per second. The resultant velocity has to be in the north direction. So that's this. Right. That's velocity of the aeroplane with respect to the ground. That's the final direction that is needed. So that's given to be 80 meters per second. In what direction should the airplane head? So velocity of the airplane with respect to the ground would be equal to the velocity of the airplane with respect to the wind. That's the speed with which it tries to go, but the wind is going to drift it. That's velocity of the wind with respect to the ground. So velocity of the airplane with respect to the wind, that is in what direction and with what speed should it be heading in will be equal to the speed and direction which we desire, or velocity and direction that we desire, minus the velocity of the wind with respect to the ground. We do know these quantities. Velocity of the aeroplane with respect to ground is equal, it's in the y direction, so it's 0 in the I direction plus 80 up to 3 sig digits in the j direction with meters per second as its unit. Velocity of the wind with respect to ground, that's in the second quadrant, so the x component will be negative. So that's 20 cosine 30 in the I direction plus 20 sine 30 in the j direction. Cosine 30 is 0.87. So you get it to 3 sig digits multiplied by 20. So it's 17.3. So that's minus 17.3 meters per second plus 20. Sine 30 is half. So it's plus 10 j hat. So velocity of aeroplane with respect to the wind, this has to add up together. So it's clear that it should be somewhere like this. So that will be the direction in which the aeroplane has to head. Velocity of the aeroplane with respect to the wind. So that's equal to the subtraction of these two quantities. So it's 0 minus of minus 17.3 I hat direction plus 80 minus 10 j hat direction. So that's 17.3 hat direction plus 70 j hat direction. So in what direction and with what speed? So we first calculate the magnitude of this velocity. And that is oops, I think I messed up. Square plus 70 square. That's 72.1 meters per second. And in what direction should it head in? So the velocity of the airplane with respect to the wind is in the first quadrant. That's the angle theta. This is 17.3 and that's 70. It's significantly bent towards the y direction. So the angle theta would be tan inverse 70 over 17.3. So it's 76 degrees So 76.1 degrees north of east. So that's that angle theta here. So the aeroplane has to head 76.1 degrees north of east at a speed of 72.1 meters per second, such that with the drift of this wind, it eventually ends up going in the north direction at a speed of 80 meters per second. I'll stop here and good luck with your homework.